Okay, here's your script. You're building AI agents wrong, chasing the next shiny tool, thinking, one will finally automate your business. It won't. So, what's the difference between an agent versus a system? And why is knowing that worth thousands of dollars? Before I show you how to build interconnected AI agent systems, you need to understand the abstraction fallacy first, because without it, everything else fails, and fast. You're spending hours tweaking prompts, wrestling with API keys, drowning in documentation. You're promised AI automation, but instead you get more work. You now see why individual AI tools feel like band-aids. That's not a coincidence. That's because you're still thinking point solution, not full system. But the real trap most miss? It's the abstraction fallacy. That's exactly what's causing your AI agents to brick on day one, and that's the core of the next section. You get individual agents working in isolation. Great. But when real business happens, suddenly they break. Dependencies crash, data gets lost, it's chaos. You're focused on the agent, not the outcome. You're impressed by the demo, but that demo has no idea about edge cases, back pressure, error handling. You're buying tech demos, not building robust systems. If individual AI agents are destined to break in production, can your business actually survive on AI alone? You now understand why chasing individual agents is a dead end. That's not just frustrating, that's a systemic risk to your business. The most dangerous part? Most people think the answer is more AI. The truth is in opposite direction. Focusing on simple, observable outcomes. Here's how to get there. Stop thinking agent. Start thinking node. A node is a simple, standalone AI function with clear inputs and outputs. One node ingests customer data. Another summarizes text. Another schedules meetings. The magic is in the connections. See, you don't build an AI to run your business. You build many simple AI nodes, interconnected into a workflow, monitored for drift in real time. Think of it like Legos. Individual bricks are useless, but connected together, that's how architecture emerges. You need to apply the same thinking to AI. Define the outcome, then build the workflow backwards from there. Every new agent is just another node in your network. Instrument everything. Log all inputs, outputs, and errors. Build dashboards to monitor performance. Make sure you see when things break, because they will. Map your dependencies obsessively. A change in one node can ripple through the entire system. Tools like Obsidian are your new best friends. Reduce dependencies where possible. Simpler nodes are more reliable. Aim for loosely coupled systems where one node failure doesn't cascade. Imagine you have one AI agent summarizing support tickets and another scheduling follow-up calls. What simple monitoring metric could instantly flag a critical system failure? Pause and think. How can abstraction fallacy save you from overinvesting in AI that isn't ready yet? You now realize that AI automation isn't about the agent, it's about the architecture. That's not just a technique, that's a fundamental mindset shift. The breakthrough? Knowing when to bet big on AI and when to cut bait before the abstraction fallacy bleeds you dry. Here's the answer. The abstraction fallacy is believing that an AI agent understands a problem the way a human does. It doesn't. It mimics. So constantly test its reliability. An agent and a system are different because the agent is a tool, but the system is an interconnected set of tools that creates a self-healing, robust automation. That difference is worth thousands of dollars because you are actually getting results, not just playing with new toys. Individual AI agents are destined to break in production, as we've shown, so don't go all in on any single tool. Use the node architecture to have fallbacks, testing, and observability. Today, map out one tiny workflow you want to automate. Identify the inputs, the desired output, and only then select the simplest AI node that can achieve it. The second layer of this architecture involves setting up a dynamic testing loop, the one that keeps your whole system from collapsing under real user loads. That drops tomorrow. Your profile will show it when it lands.